Okay, I think we got enough people. Happy New Year, everybody. Happy 2021. Hope it's better than 2020 for sure. If you haven't already, please sign in on the meeting minutes doc. And to also feel free to add topics to that doc also to make sure that we're able to cover what you want to talk about. So I put together a little quick vision doc of 2021, going over the things that we accomplished in 2020, and then just talk about where we're going. And if you scroll back like all the way through this entire minutes doc, it's kind of cool because it goes all the way back to February. So one more meeting and we would have hit our 1-year anniversary of this meeting. And I think that's super cool. And so, yeah, let's go through I'll kind of go through the vision doc. Let me go ahead and share this tab. Won't take too long, I don't think. Okay. So for 2021, some of the big overview of the big vision that we kind of wanted to do was to enable a world where robots use a self-maintaining map to find and solve security problems while you sleep. And we'll see cartography as a reliable platform to make this happen in 2021. The key part there is reliable platform. There's lots of different, we'll go more into, I'll touch more on that in a little bit. But retrospective of 2020, there's been some awesome stuff that happened over the past year because we started open source public meetings in February of last year. We shared it in many different places. We published a public roadmap on what we wanted to do. Andrew made a feature to evaluate result in AWS IAM permissions on resources, which I think is a really awesome feature. And it's gotten us like a lot of traction in the, I guess, broader InfoSec community, which is awesome. And we've added different data types, many different data types, actually, resource tags, data stores, different Kubernetes managed offerings, Lambda, Transit Gateway, et cetera. So a lot of great help and a lot of great work. Chris started work on a AWS route table feature, starting off with the network interface details. Marco published tracking moving clouds. Again, more conferences. One where me and Marco presented together at CNCF Security Day. Yeah, lots of good stuff. I guess like kind of at a high level overview, getting our main big accomplishments last year included getting the word out about cartography and then adding all kinds of new data features, growing our community, our base of contributors, welcoming many people to our team of volunteers, basically. So thank you very much, everybody. And there are some roadmap items that we did not finish in 2020, such as data being viewable in BI platforms. And this is something that we're going to continue in 2021. Mostly because of juggling different priorities. And there are other solutions though, such as the one Marco described in his blog post. Cartography itself does not provide a built-in feature to give you a table view of your assets. You have to extract that from Neo4j. And but then there's many ways to get around that. Marco describes a way to do that with Kibana, and we'd like to explore our many different options, and then I put in a bunch of links there. We had an item talking about retry frequency, scheduling, and directed acyclic graphs. This is work that we're going to continue. Basically, the short version is we did some experiments, didn't exactly find what we wanted, found some other work that this is blocked on, and work is going to continue. I'm going to talk more in detail about this later on in the meeting, I think. There was another item about leveraging the Neo4j object relational model. This was axed, but developer velocity is absolutely a key part of what we want to do in 21. We had an item to provide sample data to the community to show what you can do with cartography. This was, again, matter of priorities and things that were needed for our day jobs and getting things done. But contributions here are absolutely welcome. And so far, it hasn't been a really big blocker for us in getting community traction since we've been able to show off the tool at many different blog posts and conferences and whatnot. But again, contributions here still welcome. Going forward in 2021, there's 3 key things. We, as I mentioned in 2020, we added many different types of data providers. We added many different new contributors to the team. And now we're at a good spot where, okay, we got to catch our breath a little bit and improve the reliability of the platform. We need to make it so that users can increase the sync frequency, improve sync reliability, make it so that when you're maintaining it and if something fails, you don't have to manually rerun something. And let's get that better. And then later on, I'll do a second pass and then actually cut issues and tickets to track these things. This is just kind of the areas that we're going to focus on. And again, like this roadmap here is not saying that we're not going to add any new data. It's just kind of implied. You want new data, add new data. But this is the priorities that we are setting for 2021. Developer velocity is another key pillar. We want to make it super easy to develop on the platform. There were ideas in previous meetings about creating a generic, almost, I guess you could call it declarative sync, where a dev simply defines the labels that they want, the fields that they want on a node, and what relationships are going to be connecting different nodes to other nodes so that you abstract away the need to write Cypher queries on your own, since there are many ways to do that wrong. I've introduced many different hard to trace bugs by writing bad Cypher. And yeah, it's not easy to do. There's many ways to get it wrong. And we also talked about this stretch goal in previous meetings about decoupling the data retrieval phase from the load phase. And again, this is a stretch goal. It'd be nice to separate these things so that developers can define data loaders other than Neo4j. So if you want to put it in a data lake or other solution that you got. Again, business intelligence, having things in dashboards, being able to showcase your data in a table, because sometimes a table is more easy to view than a graph. If you're running cartography in production, this is kind of a side note here. These are some of the success metrics that we defined at Lyft to help measure our own success. So maybe this can help you in running cartography in production, counting the number of times a sync job needs to be manually run to provide data to a customer. Lower is better. The number of services that take a dependency on the data, the number of API calls, active users. And this was kind of interesting. The number of other metrics that can be calculated based on data provided by the graph. So if you have like another service that needs to count something, it'd be kind of neat to be able to say that your graph data enabled another metric to be counted on. Kind of a meta point, but yeah. Anyway, I'm going to close off on this. I've been talking on my little monologue for a little bit too long now, but 2020 was challenging and important, and there's lots of new data, but now the really exciting work can be done. So once we get everything into a super reliable spot, we can then use it as a reliable platform for automated remediation. And yeah, that's what I got to say on this item. Open for your questions and thoughts and everything else. Oh yeah, this is also living document. It's free for everybody to add comments, and yeah, this is nothing here set in stone.
Yeah, this is all super cool. Andrew, I was kind of curious, like what are your thoughts on or I guess, how have you gotten cartography to scale at Amazon? I know you said that you have like a lot of different, I mean, a huge ingest process, but like also how have you like scaled it amongst developers? Like, do you have a lot of folks developing on it? Is it easy for you all to like all develop at the same time?
Yeah, I think it's a hard question to answer. From the scaling just the data ingestion, we do have it decoupled. So we are not currently, although this is just a temporary measure, using the cartography code base. We do use the cartography schema so that we can run those pieces. but there is already a system, a big data system that does all of the scanning, and it's super dumb. So it joins each API, and then you can add in ways to use that data to rescan the API, you know, if you need to do some for each loop in there. And it puts that out for anybody to use. So the main bottleneck of AWS API calls, we don't have to deal with. However, Cartography cannot then ingest that data. So we do have to mangle it around a little bit and then sync it into a graph. And we use Neo4j's quicker sync methodologies like loading CSVs, loading JSON files, things like that. We do to push some of these changes back to Cartography. So that goal of decoupling the load phase from the get data phase is super important to us. We would love to run stock Cartography on the data that we already have, and we just want it loaded in the Neo4j way. As far as the how do we scale up it, we're definitely super focused on scenarios. So we would rather not have people directly, the access of the graph is for exploration. And then once you have explored something and you know what the problem is you want to burn down, then we do publish those metrics back into the pipeline. So it still comes from Cartography, but we're loading it back so that they can query it at a higher, you know, with systems that are more designed for big data and can focus specifically on that scenario. So we find a DNS scenario that we really want to burn down. Cartography publishes the data on it. These are the DNS problems you have. Here's the priority of these problems because we've already mapped it back to all sorts of other things. And then anybody can now go use that data to actually go try and do the burn down or open tickets or whatever it is. So we really, the short answer is we really focus on letting Neo4j do what it does best and don't make it do something it can't do very well, which is everybody accessing it and, you know, historical data that it doesn't have. We're not trying to do any of that in Neo4j. We're using it to analyze the data and then publish back. So hopefully that answers the question. I can certainly go in more depth for any of those.
That makes a lot of sense. I mean, keeping all the big data as big data and using Neo4j as really a strictly analytical layer.
Correct. I mean, one of the main reasons for that is the way that Neo4j or that Cartography loads in data and then deletes it. We can't have it be the primary data source if it's going to delete the node after we've added metadata to it. So, for instance, there was a push at one point to open the bugs against these items and then write that bug information back into Neo4j. But then when that item doesn't exist anymore, you've now deleted the node. It's just, and the reverse of trying to not delete the node, it just is a very difficult issue. So I think there is room for other open source projects that use Cartography as the data source, but provide other actions like openness or analyzing the data.
That makes sense. I mean, the reason I asked is because like at Lyft, we're currently starting to use the graph in like more complex ways. So we're filing Jira tickets, about misconfiguration using Cartography, and of course that puts a lot of stress on Cartography. We had to make sure, our internal version of, we had to make sure infra Intel graph is really reliable, and it's opened up this kind of can of worms where if there's a bad sync, okay, now there might be 1,000 Jira tickets that are updated incorrectly or like that don't represent state, and especially with some security issues that involve compliance, that's a big deal. If there's a critical vuln and suddenly that Jira ticket is not fired, and we only have 24 hours to remediate a vuln, well, if Cartography is only running every 5-6 hours because it's such a large ingest process, or kind of screwed, which is why, you kind of see in the roadmap these bullets about reliability and like also developer velocity, allowing lots of people to come contribute to cartography, safely, and allowing them to make quick changes. So like, all right. So my question is, do the roadmap items in the meeting minute, or I guess in the 2021 roadmap, like, will those help make cartography scalable to like so that anybody can pick up cartography and use it like Amazon or use it at scale? Like, do you think these roadmap items actually help people like achieve, like, run cartography at scale?
I do. I would be very weary of what exactly the scope of cartography is. Certainly, this is the problem with every open source thing trying to be in the cloud. You need a service to run it, but you have a code base, right? So the idea of a service that you could just spin up in AWS would help a lot of people, right? But a lot of people they want just the code base and they will define the service. So I see this as where cartography builds other open source projects, just like Neo4j does. It's a database, but they also publish Docker containers and they also publish CloudFormation templates and all of these other ones. You could speed up sync by decoupling a lot of those pieces and building it into a service. So as that data becomes available, it immediately moves into Neo4j. It doesn't wait for one monolithic sync. And I think you can do that with cartography's code base now. You can just have a service that does it. So I think the reliability piece and the speed piece is in the resulting service teams build. And if there was an open source service, I can just deploy this CloudFormation template and I get everything. The events happen, the scanning happens, everything gets pushed in. I don't know if anybody has the time to use that. I just don't think that is in the cartography's project. Right? You're now trying to enable many different people. The person who just wants to download it, see what their AWS looks like, or their entire service looks like, and the people who want to build a service out of this and continuously do this.
Right. Okay, that makes a lot of sense. And there have been a lot of requests for Docker containers and things like that in the past. So I guess there's also like a customer ask for those sort of things.
Right. Like if cartography made the Docker container and then some other project could take that Docker container and build, it's just a CloudFormation template that builds out the smart service around it, that would certainly help. But you'd also have to see how many customers there are for that, right? Like Amazon would maybe use that at some point, but they're also probably going to want to define their own service and what they want in a service.
Right. Since we've been focused on the code itself, but we've tried to take a step back and not be super opinionated about the way that someone deploys it.
Correct.
And if we were to go the Docker route, well, I mean, it's one thing to have like one opinion and then other people can build on that opinion and then make their own little Docker things. And then that's absolutely fine. Yeah, again, just been something that we haven't really had a chance to work on. Going on this topic of like what cartography is good at and not good at, I think that I don't know, let's think about that, right? Like its strength is that it ties data sources from multiple places because of the graph database solution. Would that be, I don't know, what's your thought on that, Andrew? Like accurate, not accurate?
Oh yeah, absolutely accurate. So that's what we use cartography for.
Okay.
We use it for its schema, for its security thought that has been put into these relationships, the relationships it can build, for these issues. And, it is those analysis jobs. Like that's the thought that was put into it.
Go ahead, sorry.
Yeah, I would certainly keep the focus there, and anything that is trying to prove cartography as a service, I think is a separate issue.
So you think we should maybe be wary of trying to use it as a as a really reliable store to make like actionable security decisions, like using it as like some sort of continuous security monitoring system, which we like take action on, like maybe that powers a SOC. That's not what its strength is right now.
Yes. You will have problems in the way that cartography syncs and deletes in running that. It also has no historical data.
Right.
So the SOC idea doesn't work as well. So if anything was built directly into cartography, it would be some reporting mechanism. As it runs a sync, it reports out all this stuff. But again, now you're talking service parts. Where does it report that stuff? Like, you don't take any dependencies on a specific AWS technology, so it can't report it out to S3. So then you're in this kind of idea. But if it could do that automatic reporting or that automatic drift detection, then it's used for that piece. It knows today, and it only knows today, and it can tell you what the problems are today. And it publishes them somewhere else that knows what the problems were 10 months ago, or knows what the state was 10 months ago.
That makes a lot of sense. So this is just the, okay. People have to, right now people will have to build that historically aware portion separate from cartography. And going forward, we should probably keep it separate ourselves. We should, like Neo4j does, we should have separate Docker containers or other services that would do these things. They should be kept separate.
Correct. I would just write it. I mean, as amazing as Lyft is at even bringing out cartography, I would bring out those other pieces in an open source fashion. That'd certainly be where we could contribute at Amazon to the sort of design of a service that uses cartography.
Yeah, I think the Jira ticket filer that we're working on could be cool, because that keeps track of state in intelligent ways, where if the node goes away from cartography, it automatically closes the ticket and does some other fun things. But and the service doesn't actually, I guess the service uses Jira as the database itself, so it keeps checking the Jira API and checking cartography, and then I guess mangling state that way. So yeah, we'll try to open source these things, maybe even a separate repos or something. I don't know, but yeah. Cool. Does anybody else have thoughts on this? Like Roshni, Christoph, Thomas? I don't know if maybe this is something you guys have thoughts on.
I actually had a question. You mentioned something called SOC before, and I wasn't familiar with that term. So I was just wondering if someone could define
That's a security operations center. So if cartography finds some misconfigurations or vulnerabilities that are critical, it can be sent to the SOC, and then they can action on it. But typically SOCs require something called a SIM, which is a security information event management system, which has historical records about all network events, all endpoint, just tons of data that's historical, which they use to track down these issues. Yeah.
Okay, makes sense. Thank you.
So the main weakness for running cartography as a service is this lack of historical data, it's not good as an authoritative data store because it only keeps track of the current state. I wonder, like, how have you gotten, I guess, can you talk more specifics about like other ideas on how you've been able to conquer that problem? So you have, I'm assuming, like a separate data store that does keep it as historical data. And if so, is that represented like relationally?
Well, so we are not, we are not the providers of the data in the first place. So the provider of the data, the scanning tool, does already, the dumb scanning tool literally just outputs the raw API calls that it gets. So that has the historical data. We can go back and build a graph. We can target our cartography to build a graph at any day that we want because that data source is out there. If you decoupled the two, then you would have that same ability. You have something gathering the data and storing it, and then you have something else building the graph from that data. And so But then our analyses that we do push back into a big data pipeline. So it has that historical data of the analysis that cartography has done. I think it all comes down to a prioritization, and it seems like Alex, you're already, and Kunal are already in the same agreement. The amount of effort to make cartography fully enterprise grade, where you could take these dependencies on it, is a huge effort when it's not directly in its value proposition. Its value proposition is, I give you a day and you scan a whole bunch of stuff and tell me how that day looks.
Right.
Exactly. So if we can make cartography, if we can make like the best way to use cartography, also the easiest way, I think that'd be really cool. Getting everybody who uses cartography, or I guess it's better, like I said it before, is better, the scenario-driven way. If we can start offering bigger companies like the best way and the easiest way to use cartography in an enterprisey way, that'd be cool. And it feels like
that makes sense. Focus on our strengths, basically,
yeah,
rather than spending time on things that are nebulous to them.
Other thoughts from anybody about how do we make cartography more enterprise grade? Other things to add to the roadmap, I guess.
I do think talking to customers. Sorry, go ahead.
So my view is that what an enterprise need is that you shorten the learning curve with Neo4j. So you need some sort of interface. I'm very careful. There has been work started on this web interface thingy, but really you need to have some sort of enabler to get the nice things on the first day, so that you don't have to learn Neo4j from scratch.
So this is on the developer side, or is this on the interface side, like the end user, or like both?
End user. So enterprise is end user. In a normal enterprise, normal enterprise is not a DevOps organization like AWS or Lyft or whatever, that you would be able to throw to a guy an Neo4j interface and, okay, go ahead, do some reports. In an enterprise, they install it, they want to look at it, and on the first day, they want to get results out of it.
100%.
There is no much time for exploring.
Yeah, make it so that you don't need a Christoph or a Marco or an Alex at an organization to go and translate these queries to everybody at the organization.
Right, which is kind of the bloodhound approach. And I do completely agree with that.
Right. And this is...
How can you decipher cartography?
Yeah, this ties into like our BI thing on the roadmap. I think that this is a very... I don't know, like, should this feature come included within open source? I think there'd be a lot of value in having that available. But yeah.
But and this is a Neo4j question as well. So there is a pretty cool Neo4j interface. I already forgot the name because it was before Christmas.
Okay.
But kind of it costs $100 per workstation or something like this, or per month per user. So some crazy money.
Which one is that?
Wow, I can't remember the name really.
Is it Curious?
Yes, I think that's the one. And there you can build beautiful graphs pretty easily, I guess. But and you can share them, and you can do all that stuff. So to me, it's not clear how does it work to jump on this train. But definitely, if you think about that, more enterprise customers should use it, or eventual product should be made out of it, then some sort of interface and predefined reports and graphs is a must.
100%.
They need bells and whistles.
Yeah, and ideally, like ideally this kind of view would be included in Cartography open source. That way someone who's playing around with it wouldn't need to purchase a license for any other extra tools just to be able to get that view. Yeah. Cool. If you guys like have any other thoughts going back to the roadmap or vision, just feedback, absolutely welcome. In the interest of time, I wanted to move forward a little bit to the next topic. I'm not going to take too much time on this standardized function signature and type hints, but I wanted to share something that I've been working on over the Christmas winter break a little bit. And that's this idea of standardizing the AWS sync function signature. And the reason for, so a little bit of background, one problem that I had with the DAG implementation before is the fact that the DAGs let you run AWS, GCP, Okta, whatever, all of those big, I would call them super syncs in parallel if you want to. Great. The problem is that doesn't give us enough level of granularity. So if you wanted to have AWS EC2 be running at the same time as AWS S3, this was not possible. It was a little bit kludgy to get that working because their function signatures were different. So to fix that, this PR is a pretty large refactor on getting all of these signatures into the same format. And it introduces this idea. The main big code change I would say is, let me see if I can find it. Right here. Is right here. This idea that an AWS stage config contains all of the different assets that you might need for your AWS sync. So it's got this, it carries along the session and then the current ID, current regions, and then the parameters that you're going to be using. And so an example of this usage would be under, let me see, I'm going to jump up over, should be one over here. Yeah, right here. So like every sync function will have this signature. Another thing you'll notice is that there are now type hints. Yay. So every sync function will have just two parameters, take along the session, the stage config. And so now with these functions having the same signature, you can schedule them, you can run them in parallel, hopefully give us this level of granularity that's better than just being able to say, oh, just give me all of AWS. And then another thing that I wanted to bring up here is that, yes, you can sync. Right now, you can currently, if you build yourself a custom sync script, you can run AWS accounts in parallel. But for users that have only one AWS account that has many, many assets, an approach of creating granularity between the different assets is more useful for them, that you can have EC2 and S3 at the same time. And then so you get the benefit of parallelization, even if you have a small number of AWS accounts. So this is something that I've got going on. And then like the next step after this would be to create some scheduling. Yeah, anyway, just wanted to share that with you guys. Any thoughts, concerns, questions?
What is the AWS func signature?
So the signature is just this, where you have was like previously before these sync signatures, they were essentially anything. They're like, there's no standard for this basically, and so now I'm making it to have exactly two parameters. And Kunal actually brought up this. He put in like a little suggestion to use what they call like in Python a protocol, where you would like enforce this a little bit better, kind of make it so that at compile time you can enforce the parameters of this sync function more formally. Anyway, this is a little bit more nuts and bolts than the previous topic, but wanted to share what was going on here. Cool. I'll go ahead and move on to Oops, wrong, not this one. Let's go to this document. Actually, not that document, just kidding. Okay, so the final topic that we have here on the list is AWS route tables. I think this is something that Christoph was working on before, and I think you had a couple of PRs that you had before, and I wanted to just kind of use this time to be able to talk in person about different questions and other things that you may have.
Well, I think for the routing table, Alex, it looks like that the first step was to implement the peering connections as nodes.
Mm-hmm.
That has been done. Kind of you made some reviews. I should kind of implement that in the code, and then we are fine. And then comes the route table. So I see that as something that is somewhat straightforward, to be honest. I mean, okay, my original plan was to do it in 2020, but there were other priorities, so finally it didn't work out. But yeah,
cool.
I will kind of put it. It's on the list. I will deal with it.
Well, I see that.
If not in January, then in February.
Yeah, thank you for your help there. Yeah, I only just saw right now that you had pushed up additional changes. Yeah, I got to go take a look at those.
No problem. That's all good. I mean, what is a bit more kind of where we are? Okay, not in a mess, but kind of we need to rethink how we proceed. So I created this nice synchronization, how to say, framework. When I deploy cartography for the others. So just to explain, I created a little Kubernetes framework where for each of our Amazon accounts, I create a cron job in Kubernetes, so Kubernetes cron job that starts a cartography pod and does the synchronization for a given account, which means that we don't go big monolithic sync jobs that take like 2 hours, 2.5 hours, but we go for little smaller sync jobs.
Mm-hmm.
And I realized that that here cartography has some bugs. Actually, we can clearly state that these are bugs.
Mm-hmm.
That the cleanup jobs do clean up stuff that so after every sync there is a cleanup, and these cleanups do clean up stuff that shouldn't be cleaned up or cleaned up.
Right.
And what I did, okay, I kind of hacked it around, and I implemented a command line switch for it.
Mm-hmm.
But we discussed that actually this is not the intended behavior, so it should be fixed in the in the core of the code.
Yeah, I
so
think
this is something that we need to look at. Actually, the cleanup jobs have to be mostly looked at. You can see there, yeah, those things. For example, in DNS, there are some Amazon ID references missing, which means that everything gets cleaned up.
Yeah, understood. No, this, yeah, like I said in the review for this thing, yeah, there's no need to add this as a command line switch because what you described here, this is absolutely not an intended behavior. So yeah, they absolutely should be tied to their account.
Yeah.
If you want, I can. If you want, like I can help work off of your branch also. If you wanted to go and like get rid of the command line switch. But
I mean, what we need to do, I mean, I should kill this branch, but the cleanup job part of this branch actually is good because I took all the cleanup jobs and checked all of them where is the trouble. There were a few of them actually where I couldn't figure out how should we do it, and then I implemented this little switch, this skip on unseen accounts thingy. So there I wasn't able to. There is in the cleanup jobs I implemented an argument or a property. If you scroll down a bit, you will see there yes in there that one. keep on unseen accounts. So that is actually, to me, if we don't have the command line switch, I don't know how are we going to avoid. So there I saw that it still deletes the account. So the unsynchronized account. So we need to look at these things carefully.
Wait, so you're saying that even though this
so somehow this triggers a cleanup for accounts which shouldn't be cleaned up.
Okay. Yeah, we'll have to dig into that. That should not be happening. There might be another job that does. There might be another job that isn't tied to that, right? Or
yeah, and there is another one in the big. So in one of the Amazon core sync functions, there is a part where there is a cleanup initiated, which shouldn't be done either, as well, in my opinion. So if you, I mean, it was before Christmas, so I lost the context in 2 weeks, but in the sync code, I had to implement some extra logic as well to not to run some cleanup job.
Okay.
Unintentionally, maybe in the init PI or
yeah. Okay.
Have a look. Yeah, that was it. So, okay, that changes a different one.
And this one.
I can explain that as well. But this sync all profiles here, I had to do some things.
Yeah. Okay.
So this post ingestion principles cleanup and the ingestion DNS cleanup. This was running unconditionally. And we need to look at, yeah.
Okay.
Actually, I had to put in this if. So if ABS sync all profiles, so if we are doing an all sync, then we can do this DNS cleanup. But otherwise, rather not, because it cleans stuff that shouldn't be cleaned.
Okay. Yeah. As we head in the direction of having like having things be better scheduled, this is going to be something that we're going to tackle throughout the year. This is going to get better. Yeah. Thank you for calling attention to this.
I mean, yeah, it's otherwise, actually, what I did, I liked it so much. It's so nice, you know. You have we have 12 accounts. It creates automatically the 10 Kubernetes cron jobs. You don't have to have cartography running continuously, so it's really like each container contains each container is doing just one sync job, and it's disposed, so it's very nice, fits in Kubernetes. So it's a good thing, actually.
Have you open sourced any of that, or do you plan to open source any of that? I just think that would be super valuable as sort of the step one in possibly creating a service project.
No, the idea is to create a blog post on Medium. How you set up, how you create such a setup. It's typically like from consultants to consultants. It's like how you get, for example, your Amazon account parameters, how you create the read-only accounts on Amazon, all these things. So I started to create a little kind of step-by-step guide. But until this is not not published, this changed in the stable version, I cannot publish it. So I cannot it includes as well how to build a cartography container and things like this. And the other change, if you scroll up, Alex, what I did, that is related to this as well. This one on the Boto, down, please, in the init file. So this Boto session. So at the moment, Cartography expects that you have a full AWS config file
Mhm.
with credentials and configs and whatsoever. And if you are handing over only the environment variables, the Amazon key and the Amazon secret key, and it doesn't fly. It throws an exception and says you haven't specified any accounts.
Mhm.
So with this little patch, this enables that you can start cartography with environment variables, and you put in an environment variable the Amazon key and the secret,
Mhm.
and you are good to go. There is no need for a specific profile. And this is needed for to start it in Kubernetes, actually, because in Kubernetes I can specify an environment variable for my cartography container.
Gotcha. Makes sense. Yeah, I think that there's like two pieces here. Like there's each sync module, and each sync module is like fairly straightforward to build. And then what you're touching on here is the init piece. Like our init file here is at least it's fairly opinionated in that it will run it all in order for multiple accounts. It assumes your Bodo is going to be in a certain format and everything. And yeah, I think that using importing the modules as code and then making your own scheduler in a way, yeah, this has kind of been the quote unquote best way or most flexible way to run cartography so far that I've seen. And so like going forward, I think that trying to make our scheduling story cleaner for everybody. Yeah, we'll take a look at this since there's like many different ways to configure Bodo.
Okay, so on scheduling, I think, Unix don't reinvent the wheel.
Yeah.
There are great schedulers out, and actually Kubernetes, the market is full with it.
Okay.
So I think so from my side, this seems to be very plausible.
Yeah, I would like to see like the unit of parallelism not be an account. At least that would help our scenarios. I don't know if anybody else has any strong opinions here. Like what are your thoughts, Chris? Like would it be would it break your setup? Well, we'd try not to break your setup. Like if we went to, I don't know, like EC2 or S3 be like a unit of parallelism as opposed to a single account.
What do you mean by this? I don't get
like if you run for you have an account and then you want to run sync EC2 and sync S3 for that single account at the same time instead of having your multiple accounts to go at parallel. Like what are your thoughts there?
I think so. Most of the modules are working on just getting a list of resources from AWS. I think they can live in parallel, so they don't really rely on each other.
Cool.
So I think that's a pretty obvious way to try to speed it up. Or what we could think about on parallelization is to go to different regions in parallel. So now the whole processing of all the whatever dozen regions in Amazon, that happens in serial, and that in most of the case doesn't make sense because you don't have too many resources that would span across regions.
But like I guess I'm wondering like what is the slowdown factor for the regions that you see? Because if you have no resources,
I mean, in my thinking, the longest thing is the IAM synchronization, and there is a pretty long thing, which actually in our case is super useless because we don't have DynamoDBs, but DynamoDBs are syncing. It still takes a lot of time. I don't know. So
are you talking about IAM or are you talking
about? But this is just me. So I don't know. And we have very specific use cases. For example, we are running only in EU Central 1. So to me, like like a filter that I want to synchronize only one region would be a super big help because I'm working only in one region. And
Again,
it's
my question
completely
there, though,
useless
like,
to scroll across this.
sure,
But this is just me. We have a very specific use case, so I don't want to. I mean,
understood. Yeah, like I think Rashdi brought that up before, where it's like you want to just specify a single region. Why is cartography going to all regions to do discovery? And then sort of the thinking around that was to be able to discover stuff that basically validate your assumptions. Like just in case someone else in your organization had spun something up in US West 1.
exactly.
Yeah, so, and like, at least like from my own testing, being able to, every single region, correct me if I'm wrong, but like I've seen that, so, list stuff in this region, it's just an extra couple seconds for every single region. And then like if we're talking about like improving performance, the big ones are like if you have, like you said, IAM is really, really big. It takes a really, really long time. And so being able to run IAM in parallel with something else, I think that's the unit that we should be looking for.
Yeah, completely makes sense. So if we take away IAM, you can basically double the speed, I guess.
Yeah. Or at least have things running on different cadences. And yeah. Roshan, I see
Or
that
you
you're...
could say, or you could say that, okay, I want to synchronize my IAM twice a day.
Right.
But the rest I want to synchronize 4 times a day or something like
Absolutely.
that. And then, so basically it would be a sort of filter, command line filter practically, where you choose what kind of resources you want to.
Yeah. Something that would have been useful to us was like syncing only certain services in certain regions. So even being able to kind of configure that would be useful because we might not even be having anything in some AWS service in another region, or we might want to ignore any resources that are there.
Yeah. Yeah, again, like one of the things that we've been opinionated about is like we will discover all of the things that we have a module for, but I see where you're coming from.
Okay, and the big deal is, Alex, I mean, we all know this. The big nice thing would be if we could take somehow the Amazon data model and automatically create the synchronization for it. So that basically we just needed to define the relations between the objects. That would be basically cartography. And all the objects, all the nodes would be imported automatically based on the Amazon data model. Because what we are doing now when we are implementing a model, actually this is like coding down the Amazon data model into Python and then into Neo4j.
Right.
This is, I don't know when we will say that enough from the modules and make one module that kind of
does it all.
Keeps track only of that does everything all, and we just kind of in some sort of meta language we put down the relations.
Yep.
Yep. So that is how Amazon is running it. We use cartography only to match its schema, but all of our pipes are pretty dumb. And then we just match cartography schema by defining those relationships between the pieces.
Yeah, but now since the mapping between the cartography schema and Amazon schema is actually a human result of some human processing. On the schema you see interesting things. So I checked a bit the transit gateway before Christmas, and it's kind of, where the underscores are and what is the naming of each proprietary in the node data and such things. These are not in sync. So not all the cartography objects have the same ID, the same name, the same. So it's there are some objects where the underscore is missing.
Oh yeah, and
or
then
property names there are where it is not, and this is we are all humans, so it belongs to the party. When you are coding, you overlook, you don't
absolutely.
we are not machines. And
Yeah.
I mean, it would be great to get over this, but this is beyond my kind of. This is not for 1 or 2 person to deal with. This needs a much more how to say, deliberation and concentration and thinking.
Now, this is absolutely our goal for this year. This is absolutely what we want to be seeing. With that, we're heading up toward the end of time. Let's continue these discussions in chat. I think that we hit most of everything that we wanted to cover today. Yeah. Thanks everyone for joining in.
Thank you.
Thanks for having us.
Thank you.
Take care, everybody.
Have a great day, guys.
Hey, you too.
Bye bye.
See ya.
Bye bye.
See y'all.